Okay, so this is going to be the log test review video. The first thing it says is evaluate each logarithm. Now, in theory, I guess you can put them in your calculator, but if you're smart, you can save yourself a lot of time and just think 10 to what power gives me 1,000? And that's 3. Here we've got 2 to what power gives me 8? Well, 2 to the third gives me 8, so the answer is 3. Then we've got 5 to what power gives us 625. So if we were doing what power, 5, nope. Yep, so 5 to the fourth. All right. Log base 7 of 1, 7 to what power is 1? That's going to be 0. 6 to the first is 6. Now ln is just log base e of e, so e raised to what power gives me exactly e? That's 1. All right. E raised to what power would give you e squared? Obviously that's 2. 2 raised to what power gives us 32? 2 to the fifth. So now number 9 is a slight variation of number 8. 2 to what power gives us 1 over 32? That's going to be negative 5. And again, you can always type these into your calculator now that we've learned how to do this, but when we did it the first time, we did it without a calculator, so I'm kind of doing it without pressing the log buttons. So 5 to what power gives us 1 over 25? Well, I know that 5 squared is 25, so 5 to the negative 2 is 1 over 25. And if I wanted to check that, I could type in 5 to the negative 2, and then math, enter, enter, and it's 1 over 25. Okay, 3 to what power is 1 over 27? Well, 3 cubed is 27, so it's going to be negative 3. All right, number 12, 8 to what power is 2? Since it's going down, it's either going to be the square root or the cube root. So let me check. The square root of 8, nope. And now let's check the cube root. Math 4. Yep, it's the cube root of 8. And a cube root is like a 1/3 power. Number 13, 81 raised to what power gives us 9? That's going to be 1/2 because the square root of 81 is 9. Express each as a logarithm. So number 14, the base is 6, so it's going to be log base 6 of 36 equals 2. And number 15 is going to be log base 7 of 343 equals 3. Rewrite each logarithm as an exponential. So again, I'm going to grab the base, 4, and it's 4 cubed, that's 64. Here I don't see a base, so it's going to be, it's base 10, and sure enough, 10 squared is 100. Here, ln is base e, and anything to the 0 power is 1. Right. Graphing. So I'm going to do this on 2 calculators so that people on the older machines can see how to type it. Maybe not that one, it's kind of bad. Here, I'll just do it 2 different times. All right, so I'm going to type this on 2 calculators. This calculator I'm going to use as like my old-fashioned calculator, and this calculator I'm going to do with log base. So on the newer calculator, I'm going to press math, and I'm going to grab letter A, log base, and then I can just type it in exactly as I see it. All right, now on the older calculator, I need to remember to type it in as log, and then x plus 1 divided by log, and then 3, and then minus 2. So on my older calculator, it's going to go log x plus 1 divided by log 3. Close my parentheses, minus 2. And I'm going to go to my table, and you'll see on both calculators, I see the same thing, and that is I see error. My first error is at negative 1. And then at 0, negative 2, and then my next good point is 2, negative 1. Do we got anything else good coming up? Oh, there we go, 8, 0. Oop. All right, so my asymptote is going to be at x equals negative 1 because that's always my first error. Then over here at negative 1, I'm going to put that dotted line. And I'm going to graph 0, -2. I'm going to graph 2, -1. I'm going to graph 8, 0. And then, just like here, it kind of doesn't show up real well. That's not even a standard window, zoom 6. Like, it doesn't show it here, but when I graph it on paper, I want to show that the curve runs along that asymptote. So I'm going to drag it down along the asymptote. The domain is going to be x is greater than -1 because it's everything after -1. From bottom to top, this graph covers everything. So I'm going to say the range is all real numbers. For the y-intercept, I'm going to look on the table where x is 0. And it's kind of nice, I have it right here, 0, -2. My y-intercept is right there at -2. Another graphing problem. Again, on my order calculator, I'm going to type it in as log x plus 2 divided by log of 2 and then plus 4. And obviously, if you have a newer calculator, you can just type it in with the log base, but I'll show it on the older one because it's a little tricky. Log, x plus 2, close my parentheses, divided by log 2, close my parentheses, plus 4. Let's get some points. Oh, there's my first error. So that tells me my asymptote is x equals -2 because wherever the first error is, that's the asymptote. -1, 4. I got 0, 5, 2, 6. That's a lot of points. 2, 6. All right, so now graph my curve. My domain is going to be everything to the right of the asymptote. The range is going to be all real numbers because the graph covers everything from the bottom to the top. And for the y-intercept, I look in the table where x is 0, and I have a y-intercept of 5. Okay, complete each statement. The function y equals log base 5 of x has an inverse function of y, and so the inverse of a log is an exponential. So I'm going to use the same base, and it's just going to be 5 to the power of x. The function y equals 2 to the power of x has an inverse of y equals log base 2 of x. 10 to the x, its inverse will also be a log. And you can write the 10, or you could leave it blank because, you know, log base 10 is our common base. The function y equals ln of x is going to be y equals e to the x, because the base, this is like log base e. All right. Identify each table as exponential or logarithmic, then write the equation represented by the data in each table. So I look at the first table and I see that I've got a multiplication pattern on the y values of times 4. Because I have a multiplication pattern of times 4 on the y values, that tells me it's exponential. And because it's times 4, that tells me my base is 4. So it's going to be 4 to the power of x. Now when I look at my second table, I see it's got a multiplication pattern of times 3, but it's on the y's. Because it's on the y's, that's the inverse of an exponential. It's logarithmic. And my equation is log base 3 of x. All right. So we have the parent function here shown for log base 2 of x. And I've got transformations of this log base 2 of x. I need to state the transformations and write the equation. So the first thing I'm going to do on my parent function is identify the asymptote and that first good point. And then in all the other graphs, I'm going to circle that point that was on my parent function so I can compare. So I'm going to circle, just go ahead and circle these right here. All right, because that's like this point. Now I have an asymptote here. So I'm going to look for the asymptote on number 26. And I see it's here at -3. I'm going to put that in. And then I'm going to look for that first good point. And there it is at -2, -4. So if I think the transformation from my open circle to this good point, it has moved 1, 2, 3 to the left, and 4 down. So my equation is going to be y equals log base 2 of x plus 3 minus 4. All right, so for 27, here's my asymptote. And I'm going to look for that point. There it is. Remember, I'm coming up from the asymptote. I'm looking for the first good point. Like over here, I got probably another one. Can't really find it the way the graph is, but always find the first one from the asymptote. And here I've moved right 1, 2, 3, 4. Right 4, and it's gone up 2. So right 4 up 2 is going to be y equals log base 2 of x minus 4, and then plus 2. All right, and now number 28, I can automatically tell just by the way this graph looks, because it's a complete upside down version of the other three, that I have a reflection over the x-axis. And what that's going to do to my equation is it's going to become y equals negative log base 2. And I'll see what else happens. So I'm going to look for my good point. And I just see it's right here at negative 5. So it's moved 1, 2, 3, 4, 5, 6 to the left. So left 6. So it's going to be x plus 6. All right, solving. It says solve each equation. So the first thing I'm always going to want to do is isolate the base and the exponent. Well, the good news is that I don't really have to do that for number 29. It's already isolated. So now I'm going to move on to step 2, rewrite as a logarithm. So my base is 3, so it's going to be log base 3 of 26 equals x. And I'm just going to do this on the older calculator because the newer calculators are good. So on my calculator, I'm going to type in log of 26 divided by log of 3. And if I wrote that down to 4, it would be 2.9656. And this is going to round up, so my answer is going to be x equals 2.966. Now, step 3 calculator. Step 4, isolate x. All right, so now for number 30, I actually have to do number 1, which is isolate the base and the exponent. So here's the base and the exponent. So I'm going to subtract 3. And I have 4 to the x equals 96. Rewrite it as a logarithm. And log of 96 divided by log of 4. And then this doesn't round up, so I'm just going to scratch out the 4. All right. Now number 31, again, I have to isolate. So I have to get rid of that 2 to isolate the 5 raised to x plus 1. So I'm going to divide both sides by 2. And I get 5 raised to x plus 1 equals 15. Now we're going to have log base 5 of 15 equals x plus 1. That's step 2. Rewrite as a logarithm. Step 3, use your calculator. So I'm going to say log of 15 divided by log of 5. And I get this number. And now I'm going to move on to step 4. This is the first time I've had to use step 4, which is isolate x. So on my calculator, I'm also going to subtract 1. And I get 0.6826, which becomes, rounded up, 0.683. All right, so 32, again, all 4 steps needed. I'm going to start by adding 9. 7 raised to 2x equals 315. I'm going to rewrite log base 7 of 315 equals 2x. I'm going to grab my calculator, step 3. Log of 315 divided by log of 7. And now I'm going to divide it by 2. We get x equals 1.4. Because this is a 1, I know I'm not going to have to round up. Cool. 33. So to isolate this one, I'm going to need to divide by -5. So -600 divided by -5 is 120. I get e raised to x minus 6 equals 120. So it's e, so it's going to be log base e, which is ln of 120 equals x minus 6. That's step 1. Step 2. Now step 3, calculator. Step 4, add 6, and we get 10.787. And again, because that's a 4, I don't have to round it up. Now number 33 is extra tricky because I have to do 2 things to isolate. The first thing I'm going to have to do is subtract 7. So obviously that's going to be 820. Then I have to divide by 4. So that gives me 205. I've got 10 raised to 2x minus 3 equals 205. So now I'm going to rewrite it, and I'm going to have log base 10 of 205 equals 2x minus 3. Log of 205. So that's 2 point, let's say 312 is 2x minus 3. So to solve this, oops, sorry, I didn't realize I was off the screen. So to solve this, I'm going to add 3. And that gives me 5.312 equals 2x. And now I'm going to divide by 2. And I get x equals 656. That was hard. All right. The formula for continuously compounded interest is A equals PE to the RT, where A is the final amount, P is the initial principal, E is the letter E, or the number E rather. Duh. R is rate as a decimal, and T is time in years. So the problem says you wish to invest $6,000 in an account that pays 2.5% interest compounded continuously. You plan to leave the money in the account until you will have at least $8,500. How many years should you invest for? So let's define some of our variables here. We've got A, we want to have $8,500. Our initial amount is $6,000. E is the number E. R is 0.025 because we're going to take that and go 1, 2. And now T is our unknown. So let's set it up. 8,500 equals 6,000 E 0.025 T. So we're going to start with follow the same 4 steps. We're going to divide by 6,000. Calculator. And we get 1.417. Now I'm not going to use 1.417. I'm just going to keep working off my calculator, and that's a really important point. Or I can use 1.417. I don't know. Let's run it 2 different ways and see if we get different answers. Okay. Equals E 0.025T. So now I'm going to rewrite it. ln of 1.417 equals 0.025T. And now obviously I'm going to put that in my calculator and then divide it by 0.025. All right, let's see. So if I just do ln of 1.417 and divide that by I would get 14 years. I bet I get 14 years this way too. Let's see. ln, 17 over 12, ln divided by, yep, I get about the same. It's a little different, but for our purposes, because we're going to round to the nearest year, we're going to go T equals 14